In pure water at 25 degrees Celsius, how much H plus and how much OH minus do you have? You might be tempted to think in pure water all you have is H2O. Even in pure water, you have water molecules constantly colliding with other water molecules, and you have, even though it's a little bit of it, this auto-ionization or self-ionization of water happening, where one of the protons from a water molecule may be lost and end up on another or a couple other water molecules. And we can express that. The one that gains it turning into the hydronium ion, and the one that loses it turning into the hydroxide ion. You don't have a lot of this. Turns out at 25 degrees Celsius, and this is completely very much temperature dependent, the concentration of hydronium ions at 25 degrees Celsius is 10 to the negative 7 molar. And you also have equal concentrations of hydroxide ions, 10 to the negative 7. And that makes sense because they're a 1-to-1 ratio. By the way, this is, I just realized it's asking H plus, but H plus and H3O plus are synonymous. All right, so you can only get an H plus and an OH minus from one water molecule. So if you have a certain amount of hydronium ion concentration, you're going to have the same amount of the hydroxide ion if all you have is water. This, by the way, is called the self-ionization or auto-ionization of water, right there. Right, and at 25 degrees Celsius, we have what's called the ion product constant of water. So this is a special equilibrium constant, Kw. Remember, the equilibrium expression is the concentrations of the products, which we have is H3O, hydronium ion, concentration times the concentration of the other product is hydroxide ions, and all over the concentrations of the reactants. In this case, water, which is a liquid. So we don't include liquids or solids in our equilibrium expression. So we have this as our ion product constant raised to their molar coefficients, which are just 1. What do you think that is? 10 to the negative 7 times 10 to the negative 7. Right? They have the same basis, so you're going to add the exponents. That's 10 to the negative 14. That's super helpful when we're trying to calculate these concentrations. We add acids and bases at 25 degrees Celsius and getting the pH and so on. So if we want to get the pH, let's do that. If we want to get the pH, we just take the negative log of the hydrogen ion or the hydronium ion concentration. Negative log of 10 to the negative 7, you get 7. So the pH of pure water is 7. And you've probably heard that before, but this is how we get it. And the pOH is the negative log of the hydroxide ion concentration, and that's also going to be 7. The pH plus the pOH equals 14, always at 25 degrees Celsius. There it is. You have your ion product constant, the Kw, from the auto-ionization of water.